Hey everyone, and welcome to this tutorial. Here we will see how to create a CoDeSys OPC UA communication with Python. We will create an OPC UA server on CoDeSys, and we will write some Python scripts to easily get data from the PLC and also do some interesting things such as logging and plotting. You can find everything that you need into the attached GitHub repo with a complete list of instructions to build the project and the OPC UA server. Here you will find a CoDeSys example project that we will be using in this tutorial that you can download. You should be using version of CoDeSys 3.5, the Service Pack 19 patch 5 in order to avoid compatibility issues, and any version of Python over 3.7 is fine. For this tutorial we will be using also UaExpert that you can download. This is an optional part of the tutorial, and for Python you could use any IDE. I advise you to use VS Code and some distribution like Anaconda or Miniconda for creating a virtual environment. In any way, everything will be explained in this tutorial. So, you will also find in the Python scripts folder the complete Python code that we will be developing in this tutorial. And just download the CoDeSys project and open it. Alright, so first let's boot up CoDeSys and our example project. This project has a simple PLC PRG program that will control a SoftMotion axis to do some basic movement. In the GVL buttons you will have a start and stop button to start and stop the axis movement, and in the axis data you will already have the axis position, velocity and acceleration, and these will be the variables that we will be publishing in our OPC UA server. So setting up an OPC UA server is pretty straightforward. You can simply right-click on the application, add object, and select a symbol configuration. Make sure to check the support OPC UA features. Right now, if you don't see anything over here, you should simply click build to build the project, and you should be able to see the global variables that we talk about. Over here, you can select the variables that should be accessible via OPC UA, and then we should be good to go for creating an OPC UA server on CoDeSys. Now we need the target to download our project to, and you could use a real PLC, or the simplest way is to use the soft PLC of the CoDeSys runtime. So you can go into your tray icons in your Windows bar, right click on the CoDeSys soft PLC icon and click on Start PLC. If the PLC successfully starts, you should see the color of the icon changing from black to red. This means that the PLC is running. Then you can try to download onto the local host your program. Here, CoDeSys will probably prompt you to create some credentials, and once you have created them, you should enter them. Once you have entered the credentials, you can download your project to the target. Once the project is downloaded, you can start the PLC, and while going online into the GVL buttons, you can force the start button to true just for a little while. After that, we should see in the axis data some values changing. This means that our simulation is running. Right now we can get back to other tools to see if our OPC UA Server is running. For simplicity, let's also remove the authentication policies from our OPC UA server on CoDeSys. So to do that, you should simply go into your own device, into Communication Settings, click Device, and change Runtime Security Policy. And before going online, make sure that you have selected Allow Anonymous Login. In this way, we would be able to connect to the OPC UA server without specifying any encryption and any credential. This, of course, is only good for your development server. Instead, when you will be commissioning a real OPC UA server, you should make sure to select the proper security policy. This part of the tutorial is optional, but we can use UaExpert, the most common OPC UA client for testing, to see if our server is running. So you can right-click on Server, click Add, and you should be able to scan to discover your server. And typically, you will find the server into localhost at the port 4840. And here it is. You can click on Advanced and set up the information for this server. Here is the name of my laptop, but I could also have a localhost. And let's keep the anonymous session login setting, and by clicking OK, you will see the server over here, and you can click Connect. This symbol means that we have successfully connected to the server. And in the address space over here, below Device Set, you can find CoDeSys Control, Win-v3, Resources, Application, Global vars, and here we have our axis data. And we can select these three variables, place them in the axis view, in the data axis view, and you can see that the value is updating. So the server is online and it is working. Now let's get to the Python part of the tutorial. So you could use whatever IDE and Python environment that you prefer. The only requirement is that you should be able to run some Python scripts while having the asyncua and the matplotlib libraries installed. I will be using VS Code, so if you follow along with VS Code, you can do exactly what I do. And I will use Conda to create a virtual environment. So first of all, I will create a new terminal to create the virtual environment. You should have Conda or Miniconda installed in your system to do this. And to create the virtual environment, I will simply say conda create --name, the name of the environment that I will call CoDeSys _ OPC UA _ tutorial. And I will specify the Python version. So I could say Python 3.12. Press enter, and Conda will be creating the virtual environment that I will be using. Confirm by writing Y, and it will take a while, and in a minute your environment will be set up to go. Once it is set up, we should simply activate it. So here Conda tells us what is the actual command, and by writing conda activate CoDeSys OPC UA tutorial, we will be activating the environment, and you can see that the environment is active because this the name of the environment is between parentheses before the commands. So right now we need to install the packages that we need for the tutorial. So I will say pip install asyncua matplotlib. And then after a while, we should be good to go. Now we can create a new Python file that I will call main.py. And over here, I will import from asyncua.sync. I will import client. If you see that there is some error, you should select your Python interpreter. So over here, you can select the interpreter for exactly your environment that you have created. Then I will also import the time library just to have to be able to add some delays. And right now I would need two things to create the client for the OPC UA server. I will need the OPC UA Server URL that will be a string, and also we will start from an example to read just the axis position from our OPC UA server. So I will need the node ID of the variable. So this is exactly what we used in UaExpert to connect to our host, and it's exactly opc.tcp at localhost port 4840. For the node ID, you could simply use UaExpert, and for each variable, you should find the node ID over here. So we can copy it and paste it over here. Then we can create a client. I will say client is client for the OPC UA server URL. Then we will create a script to try and connect. So I will say try client.connect, and over here I will print just that we have connected to OPC UA server at this specific OPC UA URL. So with this notation, I am able to write variables over here in the print statement. So then I will write except to catch any exception, so we can see exactly which exception is going on. So error E. And finally, I will also write some code to disconnect from the client, from the server. So client.disconnect, and print over here disconnected from OPC UA server. And if we run this code directly from within VS Code, you can see that we do not get any exception. We get connected and then we disconnect. So the connection is working. Now let's move on to read the variable. So we need to create an OPC UA node, and I will do this with the method getNode for the client. So client.getNode, and I will specify the node ID that we have written over here. Then I could create an infinite loop that I will interrupt with Ctrl+C in our terminal. So I would say while true, I will get our position. So position should be equal to node.read value. And I will print this in our terminal. So position, and I will just have 2 decimal digits. And in order to not write all the time, I will add a sleep for 0.1 seconds. And if we run this, you can see that we are reading the position. That is exactly what we would be seeing in CoDeSys. And I can press Ctrl+C to stop the Python script. So that's nice. That's the core of what we need to do to access data in Python. And let's see some application of this. So you could create your own digital twin, you could create your own logging system, whatever you need. And for now, let's use matplotlib to plot the actual values of the position. So I will import matplotlib.pyplot as PLT, and let's add some data that we can log. So I will have some position data that will start as an empty list and some time data that will start as an empty list. And before getting into our while loop, I will create a start time variable that I will set to the current time. So then in our position data over here, just before the print statement, I will say over here, position data dot append position, and time data dot append. I will append here the actual time minus the start time. So we will have a relative time here. And I just want to, for this loop, to collect a certain number of samples. So for instance, I could say that we could run this loop until position data, the length of the position data list is lower than 1000. So in this way, we would be collecting 1000 samples. Then, after the loop, I can simply plot the data, and I will create a plot with matplotlib, and I will want the time data on the x-axis and the position data on the y-axis. Let's add some title that could be axis position over time, and some labels. So the x label could be time in seconds, and the y label could be axis position. Let's add some grid, and let's call the PLT show. And for now, let's reduce the sampling time to 0.01 seconds. And if we start our Python script, we would be collecting samples for a while. And after a few seconds, we should get out of the loop and have this nice plot created that is just showing the position over time. So this is pretty easy and straightforward to use Python to create plots of your variables. Now let's move on and see how to read multiple data. So you could do this multiple times for all the variables that you need, but you would be introducing some overhead, because you would be doing some different read values, different get nodes for, you would be doing different reads for each variable, for each node. And in Python, for OPC UA, you could actually do bulk reads. That would be better and easier for us. So and you would also optimize your network. So let's do some velocity data and some acceleration data to read all three of them in the same way. And let's change this node ID into some node IDs, and let's make this a list. So a list of strings. I will copy this 3 times, and the first one will be axis position, then axis velocity, and then axis acceleration. Then over here we can change this node into nodes and create an array of nodes. So we could simply have a list that will get the node ID for each node ID in node IDs. Then instead of using the read value over here, we can use a cumulative read values. So I will create a data values list that will say client.read values, and we will pass to it a list of nodes. Then for us, our position would be the data values at index 0. The velocity would be data values at index 1, and the acceleration will be data values at index 2. And then here we can append the velocity to the velocity data, the acceleration to the acceleration data. And down here we can create subplots. So a subplot for the position, for the velocity, and for the acceleration. So let's change this into by creating a figure. So I will say plot figure and specify some figure size. I will say 10 and 8, and I will organize this plot with 3 subplots in this way. So over here we will plot the position, and I will say, let's say color blue, to have them in different colors. Then I will do the second subplot, so I can simply copy this code here and paste it by changing this index to 2, and this will be the velocity. And we can change this to velocity over time and axis velocity, and change the color to red. And also I will need to call the show just only at the end. And also do the same for the acceleration. So plot acceleration data, axis acceleration over here. Then let's also call the PLT type layout to adjust the subplot, and then we can start. Over here we are still only printing the axis position, but in the meantime we are also collecting the velocity and the acceleration. So just one correction, change the color of the acceleration to green, and after running the script and collecting 1000 samples, you should see this. A plot showing the position, velocity and acceleration over time. And using this method of getting values is much faster in OPC UA, especially if you're dealing with with a lot of variables and you do not want to introduce additional overhead into communication for each variable that you are reading. So you've seen that it's pretty straightforward to create an OPC UA server with CoDeSys and to use an external tool like Python to create some pretty cool stuff with it. If you're interested in more tutorial courses, exercises or automation builds, you can check out mnautomationacademy.com. Over here you will find many courses for industrial automation with exercises and practical examples and automation builds for your own PLC programming needs.